In the age of digital controls and planned obsolescence, a dozen battered giants from the 1950s are still clawing through Earth with nothing but raw steel, roaring engines, and the stubbornness of a bygone era. These legendary scrapers were built for a post-war world drowning in steel and ambition. Machines that ignored electronics, outlasted owners, and moved mountains for continents on the rise. But what secret alchemy of design, material, and culture lets these relics survive decades of abuse when modern equipment retires by design? This story begins where most machines end, with the legends that refuse to die. Steel mills ran at full tilt through the 1950s, churning out more plate and beam than the country could use. Contractors faced a different shortage: time. The Federal Aid Highway Act of 1956 set off a race to lay down thousands of miles of new interstate, while dam and mining projects stretched from the Rockies to the Mississippi. Schedules tightened, budgets ballooned, and the only way to keep up was to move more earth, faster, with machines that could run day and night without mercy. In this climate, steel was cheap, but lost hours were not. Manufacturers responded with frames and bowls built thicker than most bridges, main rails and draft arms cut from plate, up to an inch thick, sidewalls and axle housings measured for punishment, not for weight savings. Safety factors of 3, 4, even 5 times the expected load became the norm. If a scraper hit a hidden boulder or dropped into a rut, the frame was supposed to shrug it off and keep working. Operators still recall the old wisdom: steel was cheap, schedules weren't. This mindset was not just about brute strength. A machine that broke down in the middle of a highway cut could throw off an entire project. So every weld, every gusset, every pin and bushing was oversized to outlast the job and the operator. Engineers borrowed from wartime manufacturing, applying lessons learned on tank hulls and artillery carriers. The rule was simple: overbuilt. The result was a generation of scrapers that looked almost clumsy by modern standards, but underneath the grease and dust, they were built to survive anything. These machines were designed for a world where the cost of downtime outweighed the price of another quarter inch of steel. That is why, 70 years later, so many of them still thunder across fields and job sites, their frames as solid as the day they left the factory. Every lever, every control, every repair on a 1950 scraper was built around a single principle: keep it mechanical, keep it fixable. In an era before electronics crept into heavy equipment, these machines ran on pure muscle: cables, rods, gears, and analog gauges. There were no circuit boards hidden behind the dash, no sensors waiting to fail. If something jammed or wore out, a mechanic could spot the problem by sight or sound, reach in with a wrench, and be back to work by lunchtime. Cable linkages ran from the operator's hand to the heart of the machine, giving direct feedback with every pull. Gauges were simple needles on round dials, showing oil pressure and temperature, nothing more, nothing less. The absence of electronic control units, or digital controls, meant there was nothing to reset or reprogram after a breakdown. Open layouts around the engine, transmission, and control linkages made it possible to swing a hammer or a cheater bar without stripping half the machine apart. Field repairs did not require a laptop or a phone call to the dealer, just a box of tools, some spare pins, and a length of wire rope. Mechanics who cut their teeth on farm tractors found themselves right at home. If a cable frayed, they would splice in a new section. If a bushing wore oval, they would heat and press in a replacement. These machines invited tinkering, trusted the operator's hands, and rewarded ingenuity over manuals. The hammer and wrench mentality became a badge of pride, not a last resort. In the field, that meant less time waiting, more time moving dirt. This culture of repairability was not nostalgia, it was survival. And it is the reason so many of these old scrapers still rumble to life today, decades past their supposed expiration date. Their secret was not just in the steel, but in the stubborn simplicity of their design. All mechanical, all accessible, all built to be fixed by the people who worked them. Rubber tires rolling over rough ground. This was the revolution that split the field in two. The Latourneau Tournepool arrived with a promise: no more waiting for a tractor to show up, no more wrestling with clumsy couplings in the mud. For the first time, a scraper could drive itself to the cut, fill its own bowl, and thunder off to the fill without breaking stride. Introduced in the late 1940s, the Tournepool's self-propelled design changed the rhythm of the job. Operators quickly learned to trust its mechanical drive and rugged, easily welded frame. If a bearing went out or a bracket cracked, a welder in a few hours could put it right. That independence, no tractor required, meant crews could cover more ground with fewer hands, a game changer on sprawling highway and dam projects. But not every job needed the latest trick. The Letourneau Westinghouse Model N, built well into the late 1950s, stuck to what worked: a towed bowl, cable controls, and a reputation for being the mechanic's best friend. Simple, robust, and endlessly adaptable, the Model N fit right into the hands of farm mechanics and small contractors. Its cable system could be spliced in the field, its frame patched or reinforced with scrap steel, and every moving part was accessible with hand tools. The Model N did not chase trends, it outlasted them. For decades, these scrapers formed the backbone of local roadwork, airfields, and irrigation projects, proving that longevity sometimes comes from not trying to fix what is not broken. Two survival paths took shape in the 1950s. One was innovation through self-propulsion. The other was the stubborn resilience of mechanical simplicity. Whether it was the Turnipole blazing ahead on its own rubber tires, or the Model N waiting patiently for a trusted tractor, both machines became legends for the same reason. When the work was hard and the hours were long, they kept moving. On the toughest jobs, nothing slowed crews down like a bowl that would not empty. That is where the Letourneau LP stepped in. Its curved bowl floor was not just a design flourish, it was a direct answer to the sticky clays and gumbo soils that plagued early highway cuts. Instead of dirt clinging to flat corners, the LP's geometry coaxed even the heaviest loads to slide free with every dump. Operators saw it firsthand: less time fighting hangups, more dirt moved per shift, and less wasted horsepower shaking a stuck load loose. The curve was not just about speed, it meant fewer stops to clean out the bowl, less wear on ejector mechanisms, and a smoother, more reliable cycle from cut to fill. Cable control systems reached their peak with the Letourneau Westinghouse CT and DT series. These scrapers skipped the early hydraulics that were starting to creep into the industry, sticking with drums, sheaves, and wire rope that could be repaired with basic tools. For the crews who ran them, this meant fewer headaches from blown hoses or leaky cylinders. If a cable frayed, a rigger could splice in a new section right on the job. Drums and sheaves might need new bushings or a shot of grease, but there were no seals to fail and no high pressure lines to burst in the middle of a haul. It was a system that rewarded regular maintenance. A few minutes with a grease gun or a wrench could keep a CT or DT running through a whole season without a major stoppage. For contractors, the payoff was clear: more consistent cycles, less downtime, and a machine that could be kept alive by the hands of the crew. The LP's bowl innovation and the CT and DT's cable mastery set the standard for productivity and reliability. In the 1950s, proving that sometimes the smartest solutions come from refining what already works. These machines did not just move dirt, they moved the industry forward, one clean dump and one smooth cable pull at a time. Caterpillar's DW10 rolled onto job sites in the late 1940s, answering the call for faster cycles and smaller crews. With its integrated tractor and scraper, the DW10 offered contractors a way to move dirt at a pace that left towed pans behind. Its diesel heart and rugged frame kept it running through long shifts, while the compact design made it nimble enough for tight corners and short hauls. For many operators, it was the first taste of true self-propelled earth moving. One machine, one man, and a steady rhythm of cut, load, haul, and dump, a quiet testament to durability. But as projects grew, so did the need for more capacity. Enter the DW15, a step up in both size and adaptability. The DW15 could be matched to a variety of bowls and attachments, letting contractors tune their fleets for everything from highway cuts to land reclamation. Mechanical simplicity meant less time in the shop and more time moving material, and the flexible setup allowed companies to stretch their investment across different types of work. On a busy interstate grade or a sprawling dam site, a mixed fleet of DW10s and DW15s could keep dirt flowing without missing a beat. A clear example of simplicity paying off. For the biggest jobs, the DW20 brought four-wheel drive and a 20-yard bowl to the table. This was the machine that set the pace on major civil works, long hauls, steep grades, and relentless schedules. The DD-20's heavy-duty frame and robust transmission made it a favorite among contractors who needed to move mountains, not just molehills. Operators valued its sure-footed traction and the way it handled rough ground without complaint. Each step up the ladder, from DW-10 to DW-15 to DW-20, gave contractors a sharper tool for the job, building a fleet where every machine had a clear role. Efficiency was not just about horsepower or steel. It was about matching the right scraper to the right task and keeping the whole crew in sync. That cycle of capacity and productivity set the stage for even greater feats, as the need for speed and volume pushed the industry toward its next icon, a story of capacity preserved by craft. In 1950, Caterpillar released the DW-21, a machine that would become the gold standard for earth moving in the post-war era. Engineers set out to prove its mettle, not just on paper, but in the field. The test site was Barnsley, England. The challenge was a 500-yard haul over shale, up a punishing one in 8th grade. British contractors, government officials, and Caterpillar's own team watched as the DW-21, loaded to capacity, powered through the cycle in under 12 minutes. That performance, 500 yards, one brutal climb, less than 12 minutes, became a benchmark whispered across job sites from North America to Africa. The DW-21 was not just a test track hero. It carved its reputation on some of the most ambitious projects of the decade. In Kenya, fleets of DW-21s moved earth for the Sasumua Dam, a water source that still supplies a tenth of Nairobi's population. Across the Atlantic, the St. Lawrence Seaway demanded more than 3,000 Caterpillar machines, with the DW-21 taking on the longest, toughest hauls, day and night, rain or shine. Operators recalled the relentless pace, fill, haul, dump, repeat, with the DW-21's diesel growl echoing across miles of raw cut and fill. What set the DW-21 apart was not just its two-wheel drive or 20-yard bowl. It was the way it handled punishment, frame flexing but never failing, transmission shrugging off shock loads, bowl geometry stable at speed. Contractors learned to trust it on jobs where a breakdown could cost a week's progress. As former Caterpillar president Harman Eberhard said, they were using CAT equipment. The DW-21 did more than keep up. It set the pace. Even after production ended in 1960, these machines kept working, proof that in the race to move mountains, craftsmanship and design could write a legend that refuses to die. Euclid's answer to the post-war earth-moving boom was mass, raw, unapologetic weight. The S-18 towed scraper stood out as a brute, demanding a D8 or bigger crawler just to get it moving. Its cast and welded frame did not flinch at hidden stumps or boulders. Operators learned that every load was a test of nerve and steel, especially on soft ground or steep grades. The S-18's heavy bowl and apron, stripped of anything unnecessary, made it a favorite for contractors who valued reliability over frills. If something bent, it got straightened with a torch and a sledge. If something cracked, it was plated and welded, then sent back to work. For decades, the S-18 kept pace on dam jobs and open pit mines, surviving where lighter machines gave up. The Euclid 66 FDT took a different approach. 2 engines, one up front and one riding the scraper axle. This twin power setup gave contractors more than just horsepower. It delivered a new kind of economics. With both axles driving, the 66 FDT could load itself without a pushcat, cut cycle times, and keep more dirt moving with fewer hands. Fuel bills went up, but labor and support equipment costs dropped even faster. Crews learned to coordinate the twin throttles, squeezing every advantage from the extra torque. On the big interstate cuts and mining hauls, the 66 FDT's ability to keep working when others bogged down meant more money made and less time lost. For sheer staying power, the TS series redefined structural overkill. Euclid engineers doubled down on thick steel, oversized welds, and massive goosenecks. Every joint was built for punishment, not just for the first job, but for decades of abuse. Restorers today still marvel at the size of the weld beads and the way mainframes outlasted generations of wear parts. The TS series did not chase trends. It set a standard for longevity, with many units still working or restorable after half a century. For the crews who ran them, these machines proved that sometimes survival is not about the newest technology. but about building enough margin into the steel to handle anything the world can throw at it. In towns where the main street runs past the grain elevator and the old quarry, Alice Chalmers scrapers still earn their keep on family land and small contracting jobs. Machines that once carved highways now shape farm ponds. Their orange paint faded to rust, but their engines are still willing. The reason is not just what went into the steel. It is the people who keep them alive. Across the Midwest, donor machines sit behind barns, waiting to give up a transmission or a set of tires. Local clubs and online forums have become lifelines where owners swap parts lists, blueprints, and the names of machinists who can turn out a replacement bushing or weld up a cracked draft arm. When a wear plate finally gives out, a volunteer crew might gather in a farm shop, torching out a new one from scrap and bolting it up before the next rain. Restoration is not a solitary pursuit. At vintage equipment rallies, it is common to see 3 generations gathered around a running Alice or Cat, each with their own story of breakdowns, rebuilds, and long days in the dirt. These scrapers survive not just because they were built strong, but because owners pool resources. They trade axles, fabricate hard-to-find linkages, and even recreate obsolete decals for the finishing touch. Regional parts pools stretch across counties, with word spreading fast when a rare donor machine comes up for sale. This community effort turns each restoration into a living piece of history. Machines that could have been scrap are brought back to life, not for show, but to work, hauling gravel, leveling ground, or just proving a point. Every rebuilt scraper is a tribute to the people who refuse to let them fade away, keeping the spirit of the 1950s engineering alive in the hands of those who value craft, resourcefulness, and the satisfaction of seeing old iron thunder back to life. Today, as most modern equipment is replaced every decade, the scrapers from the 1950s still earn their keep, proof that true durability outlasts trends and technology. In a world obsessed with the new, their survival is a quiet rebellion against disposability. Their steel and grit remind us that what we build to last shapes what lasts in us. Share your thoughts below if these legends moved you.